got it on. Okay, you're back. Y equals x squared. That means x times x. So you're always going to get a positive answer. Okay, that's 4, that's 1, that's 0, that's 1, that's 4. When you are graphing, even those of you that your graphs looked okay, here's what I don't want to see. All right, let me just make a chorded plane first. All right, -2, 4, -1, 1. Parabola is symmetrical. So if this is the middle of your parabola, which is called the axis of symmetry, then you're just as far away from this side as you are on that side. So if it's lopsided, you did something wrong when you multiplied. Now, make sure it curves and it doesn't look like a V. And I wouldn't go up much higher than that, because if you go up higher, see, some people are doing this. Okay, they have this parabola and then they do that. Well, that's not right, because for every x, there can only be one y that goes with it. It wouldn't be a function otherwise. A parabola always gets bigger. And then some of you exaggerate, and I get this. Okay, if you don't know where the next point is, and you want to make your parabola bigger, then pick another point. 3 times 3, 9. 1, 2, 3. And that's 5, 6, 7, 8, 9. If your parabola points towards the 9, it's a good one. You just look at your parabola. If it points towards 3, 9, it's a good parabola. And that's how I grade it, is I look at a point that you probably didn't pick and make sure it's there. That's a perfect parabola right there. Well, it's not perfect, but you know what I mean. All right, now, a parabola is caused by a quadratic equation. This entire unit puts everything you've learned together. All right, up until now, you're most familiar with linear functions, like y equals mx plus b. Am I in?
Yeah.
Okay, a quadratic function has what? Always. What does it always have?
X squared.
Thank you. X squared. A quadratic equation looks like this. Now, up until now, you've only been given an x squared without an x. It doesn't have to have an x, because b can be any number. This one, b, is 0. C is 0. This is a quadratic equation. The a can also be any number except 0. Why can't a be 0? Alex?
It wouldn't make it a quadratic equation.
Yes, it would take away the x squared. It wouldn't be quadratic anymore. It would be a linear equation. All right? On a linear equation, and those of you that are taking the I-STEP, you'll notice last week there was an example about a parabola, and it said, does it have the same slope? Well, parabolas don't even have slope. Slope is what you get on a line. Up, over, up, over. It's always constant. For example, let's say this is 2, 3, 4, 5, and this is 10, 15, 20, 25. This is linear because the slope is 5. 25 over 5. Okay? The slope is 5. This goes up 5, up 5, up 5. Up 1, up 1, up 1. Now, on a linear equation, these are always the same, and these are always the same. It climbs at the same rate. It would never go up 5 and then down 2, up 5, down 2. That's not linear. On a parabola, if I give you a table of values, I expect you to be able to tell, well, I'll just use this one, to tell if it's a parabola or not. Now, we know this one's a parabola, but look how you would have known. Okay, this one goes up 1, just like a linear, up 1, up 1. It's constant. Now, this one goes, what?
Down 3.
Down 3, down 1, up 1, up 3. That tells you nothing. There's a pattern, but it tells you nothing. All right? Let's say you had the next change. This from here to here is up 2, from here to here, up 2, from here to here, up 2. That's how you tell if it's quadratic. This will remain constant, and this, the second difference, is the same, not the first one. And so someone asked me last period, well, can't you just tell, for example, 1, 2, 3, 4. Okay, we're good there. And then it was 5, 10, 10, 5. And he said, well, there's a pattern there. It must be quadratic. I said, no. This goes up 5, up nothing, down 5. Oh, it is quadratic. Another one. Okay, 12, 9, 12, 9. Subtract 3, 0, 9, 12. Let's say you have that, okay? And that looks quadratic, doesn't it? All right, down 3, down 9, up 9, up 3. Now, what's the difference from here to here? Minus 6. What's the difference from here to here? It's not minus 6, is it? It's not quadratic. Just the pattern is not good enough. The second difference has to be the same. Okay? You understand? All right. I saw a light come on. Did I see a light come on?
Yeah.
Yeah. All right. Actually, I have another example right here. All right, here's one that is. And they all look like they might be, but -4, -2, 0, 2, 4, 8, 2, 0, 2, 8. All right. This is obviously always up 2. This one is down 6, down 2, up 2, up 6. All right? How do you get from here to here?
-4.
Minus 4. No, plus 4.
-4.
Plus 4, plus 4. That's quadratic. And, you know, this could look quadratic, and it's not. Here, let's make that a 9, and let's make that a 9. Don't jump to a conclusion, oh yeah, that's quadratic. 9, 2, 0, 2, 9. Let's look. From 9 to 2 is -7. -2, up 2, up 7. Okay, now check out these differences. How do you get from here to here?
+5.
Add 5, add 4. Done. It's not quadratic. Some kids said, well, if I win another one, it doesn't matter. The second difference has to be the same. All right? The other way to tell if it's quadratic is just to look at an equation. All right? Let me give you some equations. If you can make it look like y equals ax squared plus bx plus c, it's quadratic. Example. Y minus x equals x plus 5. All right? We want y by itself. What should I do? Add x squared. Y equals x squared plus x plus 5. That's quadratic. A is 1. B is 1. C is 5. The ABC will come into play in a couple of days. You need to know A, B, and C. All right? Y equals, no. Y minus x squared equals x squared. Let's make that negative x squared plus 2x minus 7. Is that quadratic?
No.
No. What's going to happen? When I add x squared to both sides, I get y equals 2x minus 7. That is a line. y equals mx plus b. Slope, remember? Y-intercept. Why don't you watch when I teach? Watching and listening go together. Okay? All right. When you have a parabola, it could either go up or it could go down. Happy face? Sad, well, that's actually the face, isn't it? There. Sad face. If A is negative, it's upside down. You should know that before you start putting ordered pairs down. If you have, for example, y equals negative x squared plus 2, I know it's going to be upside down. Okay? And if that's positive, I know it's going to be right side up. And if something's happening that you're not getting it upside down, then you're doing something wrong on your calculator. And speaking of calculators, you put in the x squared in parentheses. So when you're doing, let's say x equals negative 6. When you're doing this on your calculator, you put negative sign, left parenthesis, negative 6 squared, sorry about that, plus 2. Put it in your calculator like that. Or, if you want to do it mentally, which I strongly suggest, you take x times x, which is 36, then times negative 1, then add 2. Okay? A parabola has a minimum value and a maximum value. Okay? Does this, what do you think? This has a minimum value or an maximum value?
Maximum.
Let me do one that's not on 0, 0. Let's say we have a parabola that goes to here. Somewhere there, somewhere there. Okay, this is my axis of symmetry, which means it cuts it right in half. All right, this is my vertex. Now, does this vertex have a minimum value or a maximum value? Minimum value of what?
-3,
Negative 1, right? It can't go any lower than negative 1. So, minimum of negative 1. Vertex is an ordered pair. What's the vertex here?
-3, -1.
Negative 3, negative 1. Now we're going to do something from way back. Domain and range. These are the first 4 questions of every parabola on your homework tonight. Okay.
To do the brackets.
Yeah. Well, you know, I didn't use brackets today. I'm not sure you have to have them when you have an inequality, do you?
No.
They don't care in algebra 2?
They do it a little bit different. They put X or and then they put a colon and then they.
Okay, so they'll do that next year. All right. Okay, now, I want you to think of all the points in the world on this parabola. Is there any x value, that's left and right, that can't be on that parabola? Can you pick any x value that can't be on it?
-9.
-9, I believe it is. If I go over 9, somewhere up there it's going to cross that -9.
Oh yeah, that's right.
Another one. Another guess. Any x value that is not on that parabola. Remember, it gets bigger and bigger and bigger and bigger. Is there any x value that won't work?
No.
All real numbers. Always.
For a problem?
Always. This is the symbol for all real numbers. Instead of one line, you make 2, and you make an R out of it. If you don't like to write all real numbers. We all know you like shortcuts. Now, the range has a value that you can't say any y, because is it ever going to have something -6? Never. What's the lowest number it's going to have for y? Negative 1. So y is greater than or equal to negative 1. Notice negative 1 appears 3 times in your answer. Okay? All right, let's do another one. Let's do one that's upside down. Honestly, if you know how to factor, this chapter is not going to be that hard. All right, let's say I have a parabola here, and it goes down. Now, I know automatically that my equation, whatever it is, has a negative number in front of x squared. In standard form. Don't assume anything's negative until you get it in standard form. All right. Does it have, well, first of all, what's the vertex? What's the vertex? Is it going dark or something? No? What's the matter?
It's just buzzing.
Huh?
There's buzz.
It buzzed?
No, someone's phone.
Oh. What's the vertex?
Five.
5, 5.
Good job.
Right? Right 5, up 5. What is it, a minimum or a maximum, Charlie?
It's a maximum. It's about
Maximum of what?
5.
Okay? Domain.
All real numbers.
All real numbers. Range.
5.
We can't just say 5.
Less
Less
than
than or equal to
5.
5. You with me? So far, so good? All right. Sometimes you're going to have some story problems with some crazy numbers. And you might be doing a T-chart and getting -3, -15. Now you know that my coordinate planes don't go -15. So you're going to be getting a blank graph from now on. And if you know that you have to go down 15, then I suggest you put your x-axis up here. And then you can go down 15. -3, -15. All right? You'll adjust your own x-axis. If this number gets really crazy big, then you can count by 5s or count by 2s. All right? You're going to be making your own coordinate planes from now on. I think I got everything I wanted you to know. Okay, parabola, white, axis of symmetry. All right, so let's just graph one to make sure you know how to do the math. You don't have to graph, you just need to tell me what numbers to put. All right? All right. Mentally, think about what -2 would give you. And if you don't get what we get, then you might want to start using a calculator. Okay? Mentally, what do you think -2 results in? Yes?
-10.
She's correct. -10.
Nice.
It's -2 times -2 is 4. 4 times order of operations. 4 times -3 is -12 plus 2. -10. So what do you think this is going to give you?
10.
Same thing, man.
Yeah.
All right, do the positive one first. All right, what is 1 and -1 going to give us?
I don't know. 6. -6.
-1. 2.
How do you put up with someone who can't add 1 plus 3?
I'm tired, man.
All right, what does 0 give you?
2.
2. No, it does not give you 0, 0. I knew somebody's going to say that because the 2 examples on your bat were 0, 0. They do not all go through the center. All right, -2, -10 is right there. Positive 2 and negative 10 is 2 away from there. All right? 0, 2 is here. That's your vertex. And 1 and 1. It's a big, long, skinny parabola. Make sure it always looks like it's getting a little bit bigger. I don't want to see that. All right. All of your parabolas do not go through the y-axis in the middle. If you have a parabola here, let's say you have this right here. Okay, what is the vertex?
5, 2.
2.
It's negative 5, 2.
Oh, okay.
Okay? Does it have a minimum or a maximum?
Maximum.
Maximum of 2, because that's how higher up or down it goes. And then the domain,
All real.
all real numbers. And the range,
2.
Y is
What?
less than or equal to 2. So you think you can do that?
Yeah.
And then you're going to graph 2 of them. Now we can go over the test. Okay?
Yes.